All right, so something like this. Remember what we said was we added something to our discussion before a much needed break. We were talking about how momentum is conserved, right? That's a thing. And we know that the law of conservation of momentum says in a closed system, so if no forces are acting outside the system, then momentum is conserved. So we did some simple examples of that earlier in the chapter where we had objects moving all in one direction, right? Moving along the line. But this is where we step out and we add the vector stuff to this, right? So now we can take objects that are going to be, we're going to look at conservation of momentum in 2 dimensions, right? And what helps us here is that if momentum is conserved, then all aspects of momentum are conserved. Meaning, see ya. Meaning all,
Good luck.
good luck.
Look on the test. It's actually today.
Meaning all components of momentum are going to be conserved, like the x and y components, or east and west components, or however we want to break this up. So a problem like this is really no big deal, right? Because this one, we've got a car that's traveling due east. The momentum vector for one car is due east. The other one's traveling due north. And so the momentum vectors are already at right angles, right? So it's really not a big deal then. We just know that if I add those 2 vectors up tip to tail, I'm going to get the resulting, resultant momentum of the system because they stick together, right? Does that make sense?
Right.
So that one's really not a big deal. I mean, I'm just going to I'm not even going to do this problem. I did this one last week, one like this. You can go back and look at that, but I want to get into one that's a little bit, where there's a few more steps. So with this one, let's just make this the red momentum vector. There it is, due east. Okay, this is going to be the blue one. I've got these 2 momenta. If I want to add them up, and we know we're going to add them up because they stick together, right? So the combined momentum of the system just gets contained in one bigger object, whereas it was initially in 2 smaller objects, right? And if I add those up tip to tail, that's what I get, right? How would I find the magnitude of this one? Well, just mass times velocity in the east direction. How would I find the magnitude of the blue vector? Mass times velocity, right? And then I'd use Pythagorean theorem to find the magnitude of the resultant momentum, and I could use arctangent to find the angle, right? Okay, no big deal. You've done a lot of that stuff.
So then when you solve for,
So this would be the angle, wouldn't it? They want to know along the trajectory, how many degrees north of east. So that's going to be, there's how far it is north of east.
yeah, it's just the arc.
So right, it'd be the arctangent of the blue magnitude divided by the red
But when you
magnitude.
do like the Pythagorean theorem and then you solve for like that squared equals that squared,
Mhm.
and then you get a number,
Mhm.
what is that number that you get out of it? Is that,
That's going to be the magnitude of the momentum.
so then you have to divide by like the total mass to get the velocity.
To get the velocity, I would, exactly. Right, so this is going to be, should we look at that real quick? Should we run through one of these, or?
Wait, so, just a quick question, for our purple line and our red line, do those represent the momentum of the cars, or?
The momentum.
Okay.
Yeah, momentum's a vector quantity, right? Momentum equals mass times velocity. So what Peyton was saying is, right, we're going to get this purple momentum. Let's just call this, it's not purple. Let's call this P final, right? Well, that's equal to our combined mass, right? So that's, the combined mass would be M1 plus M2 times V final, right? Because they're stuck together, right? Now we've got this purple car, right? Instead of one red and one blue. And so if we divide the magnitude of that vector by the total mass, that should give us the velocity of that large object we created by joining these 2 cars. that make sense? Okay. All right, so let's look at one where we have to, there's a few more steps. I mean, and this is pretty, I mean, there's a lot of stuff going on here. I mean, think about this. This combines a lot of trig that we've done all year.
What would be a good, what would be a good unit for, moment?
Mass.
Kilogram meter per second.
So it's just.
That's what it is. It doesn't get its own special.
Okay.
Is that what moments per moment?
Yeah.
There is a problem.
kg times it.
I just wanted something to label the graph that.
Yes,
Right.
233 momentums.
Yeah, pretty much.
Okay.
It's too early to be cracking jokes.
Sorry, John.
You gotta make sure, you gotta make sure to be quiet about it.
Sorry, John. I thought it was Monday.
Oh, what did I do?
I didn't get donuts, but.
John. Sorry, I forgot we should have 2
Always
months
feel
left.
the need for physics.
Guys, we only have 2 months left.
Let's go to
This is-
days. Months seem long.
I'm
Do we have like
60
60 some
months,
days?
you're gonna
That's all.
Let's all just knock it spin.
Okay, so this is one where to draw this thing would be kind of complicated, right? I mean, we're gonna get this one car now. They're no longer traveling in nice, convenient directions. This first car is traveling. It's got a certain mass, and it's traveling at this angle. It gives us an angle west of north at 19.9 meters per second, right? So that's going to be off at some weird angle. The next cars, they give us the mass, they give us the speed, and they give us the direction. Once again, it's some bizarre direction, right? And so adding these things up tip to tail does me no good because I can't add them conveniently, right? They don't form a right triangle. So what we do, if we go back, we've done this now, we've gone through this process a couple times. What do we do in a situation like this?
Break each one into.
Yeah, good. We're going to make a table, aren't we? We're just going to take each vector and break it into an x component, which we could, x is east, right?
Yeah.
So east or x, whatever you want to call it, an east component and a y or a north component. And then we'll just add those columns up to get the overall components of the resultant. Then we just build, we build the resultant vector from whatever we get at the bottom of the table. And remember, what's nice about this is you can have arbitrarily many vectors, and all you do is break each one into components and just add those numbers up. So dealing with many vectors at once really isn't very complicated if you use this method of vector resolution, we call it. All right, so let's do this. So we've got vector, well, here's our vector 1. Here's all the information. So if we were to just orient that, and let's just do these one at a time. Let's just take this guy and let's orient that on an XY plane, east-north plane. So what's that going to be? 25.3 degrees west of north.
West of north. That's that way.
Yeah, so I'm starting at north and I'm veering to the west of north, right? Does that make sense? So this one's going to look like that, where this is 25.3 degrees, and the magnitude is that times that, right? So what is, let's figure out what that is. What is the magnitude? If I throw that in a calculator,
19,000, 20,000.
19,000, 20,000.
20,218.
oh, there it is.
Heyo. Called it.
She did that all in her head too.
She's not even
She's getting really good.
She didn't even calculate it.
Okay, I might as well get this in my calculator because we'll be using this number. So 1,016 times 19.9. Okay, there it is. So, okay, so there's all we need to know for that one, right? What about the other one, the blue one? The blue one is at 71.4 degrees west of north, so that's gonna be the one that's maybe down here. Does that make sense? Yeah, I wish those were a little further apart, but that's all right. So this one's gonna have a magnitude of, if that's 71.4, what's that angle gonna be down there? Let's use that one instead.
71.4 minus 180.
So what is that?
18.6.
18.6, good. 18.6 degrees. And the magnitude of that is going to be Ian, what's going on?
You didn't get
Are you feeling okay?
With them, or?
No, with you.
Still awake.
Oh, yeah. Which is surprising, because I didn't go to sleep. I didn't go to sleep until like 2 every night of spring break.
That's not healthy.
Well, yeah, but you see, the key is the time you woke up.
Healthy choices.
You woke up at 10.
Because you see, you can go to bed at 2 or 3 a.m. and wake up at 2 or 3 p.m. and feel fine.
No,
Okay,
I-
so
I-
15,779.4.
Sleep for like 5 hours and get up and be fine.
Yeah.
Oh my gosh, yesterday, my eyes were on fire because I forgot to take allergy.
Oh, no.
Allergy medicine the night before. And I slept in my room. Like,
I also do need to learn this, so I aced the test first.
Okay, good. That's a good thing.
Fourth.
All right, so let's have a look at this then. So if we want to make our table, right, here's our vector column. Here we want our x component and our y component, right? So vector 1. What's going to be, for vector 1, what's going to be the x component of this vector? Yeah.
Cosine.
So it's going to be, okay, so it's going to be a,
It's gonna be the x component of 1 plus x.
so here's the angle right there, right?
Right.
Yeah.
So we're going to break this into, we've got,
It's gonna be sine is that one.
it's going to be a sine, isn't it? Because the horizontal component is the opposite, so that's going to be a sine multiplied by sine, right? So we're going to multiply our magnitude, 20, 218.4 times sine, 25.3. What's the SIGN sign going to be of that? Positive or negative? Negative, because it's pointing backwards. Okay, good. And then the y component's going to be positive or negative?
Positive.
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 Yeah, negative.
Okay, good. And then v2,
Yeah.
I'm going to get, the x component is going to be
Cosine.
negative, and it's going to be a cosine this time. Good. So negative,
I didn't write that.
We can try to figure it out. It's your cosine, this is.
okay, negative, and then positive sign for the y component. Everybody agree?
Yeah.
Okay, so all we got to do now to get the resultant is just add those up, right?
Yeah.
So we can do this. This is calculator issue. All right, so column 1. Column 1, we've got negative that number, sine 25.3, plus that number, oh, minus, never mind, right, minus that number, cosine 18.6. So there it is. Okay, there's our x component of the resultant vector, so it's gonna be the one that's about 23,596, right? Everybody agree? In units of momentum. Okay, other side. Whoops, what am I doing? So we'll go grab that calculation and edit it. So that's going to be positive, right? I can delete that.
Positive cos.
I got to change the sign to a cosine. Good. Got to make that a plus. Got to make that a sine. And there it is. Wow, those were really close. That's weird. So it's the 23,312 number, right? Okay, so now what? Now all I've got to do, right, is build my resultant vector from those components, because this is, remember, this is just
That's your A.
r sub x and r sub y, right? Okay, and I probably should call that P. I mean, it's momentum. I just called it resultant like we did before, but it stands for the combined momentum, right? Total momentum. Okay? Okay, so what do we got here then? Oh. So we're gonna go backwards this far. And we're gonna go up this far. And then we end up with, here's our resultant, right? Everybody agree?
Yeah.
Okay. So those are calculator numbers. Let's just do that on the calculator. Okay, so square root of, and remember how we do this? We want these numbers to all be positive. So I'm going to put in absolute value bars when necessary. How did I get those? You remember?
Oh, math something.
Math, number.
Necessary to put those in.
ABS.
Okay, you don't, because you're squaring it, you don't have to. You're right. But you have to put it in parentheses anyway then, right?
So the absolute value things we were.
Just right, so they just act like a grouping symbol there. Right, so we end up with absolute value of, and this way I don't have to rewrite anything. I can just go grab it. So we get the absolute value of that guy, right? Squared. Plus, and I don't need it for this one because it's already positive. Okay, any questions on that? Does that make sense? I'm just taking the square root of that squared plus that squared, right? And so, there's our answer. So, rounded to how many places? Remember? Probably 3, I'm betting.
3.
3? Does that look good? 3.
Trace.
Okay, so rounded to 3 places, we get, what, 332? Okay. And the units would be what?
Kilograms per meter squared.
Kilogram, it's gonna be units of mass times velocity, so kilogram, one more try again.
Kilogram meters per second.
Kilograms times meters per second, so we just say kilogram meters per second. Okay, all right, and to get theta,
That's what I said there.
to get theta, what do we do? So to get theta, we're just gonna take the arc tangent of that number divided by that number. Once again, they gotta be positive, right? So we'll go second tangent, absolute value. Oops, so I didn't need the absolute value there, did I? Whoops. That guy divided by absolute value of that guy. Okay, and it gives us 44.65. So what if that's the angle we're plugging in here? what are we gonna do to that to get how many angles?
Add one. 195.
That. What are we gonna do?
Are you saying to get the west and north?
We wanna know, the question's gonna ask how far north of east, I believe it should.
Oh, it's north of east?
Yeah, it's gonna wanna know
Okay.
north of east. So starting, and that's the way we'd always do it, starting from east, which would be 0, right? We're gonna tip that, so how far are we gonna tip then?
Well, on the other side of
What
it,
do
so
you-
like 90 minus that, and then.
90 minus that?
I guess you.
Okay, subtract that from 180, right? Yeah, think about why. Here's, this whole thing, from there clear over to there is 180, right? And then we'll subtract theta back from that. You know what I'm saying? It'll be the easiest way to do it, probably. So we'll just go 180 minus that number. And so the answer is, to 3 places is just 135 degrees, right?
Okay.
So what do we get here? We got,
It's just, he did it that way to find that angle, but you could at least.
now we haven't really finished though, have we?
Uh-uh.
We didn't really finish because we didn't actually, we found the momentum, but we didn't really divide the momentum by the combined mass, did we? Right? Remember, so we got one more small step to do here. Remember that momentum equals mv, so v equals momentum divided by m, right? So we've got to take our number, I think it was right up here, wasn't it? There it was. So we've got to take our combined momentum, total momentum of the system, and divide that by the sum of the two masses, which I don't remember what they are, so I gotta go and look. So 15, 47 plus 1016. Okay, so this combined speed then is, it'd be 12, to 2 places, 12.9. Everybody agree? Okay. That's what you gotta be able to do, 12.9 meters per second. 12.9 meters per second. Should we try this and make sure we got it?
Yes.
Oh. So we said 135 and 12.9. Nice. Works. Okay, makes sense? Grab a Chromebook and do that.